This question is asking for I3, so we're looking for the current in this branch here. So it looks like a Kirchhoff's current law question. So you have 20 amperes going in this direction, well, at least in this direction, and 10 amperes going in this direction. So if you apply Kirchhoff's current law to this node here, you would have 20 minus 10 minus I1 equals 0. So you've got 20 going in, 10 going out, and I1 going out, and the sum must be 0. So we can rearrange that to find I1 equals 10 amperes. So that's the first thing we found. I1 equals 10. So now we know that we have 10 amperes going this way. That splits into I2 and I3. So we can now apply Kirchhoff's current law again at this junction here. So we can say I1 minus I2 minus I3 equals 0. And I1 we know is 10, so we can replace that with 10. But that still leaves us with two unknowns. So we need to use some other knowledge to figure out the relationship between I2 and I3. And it looks like I2, so this resistance and this resistance are in parallel, because they're connected at both ends. So that means that this potential difference across this resistor and this resistor, it's the same. And potential difference is V multiplied by R. Sorry, I multiplied by R. So if you multiply this current times this resistance, you should get the same as this times this. So we can say that I2 times 10 equals I3 times 20. You can rearrange that to say something like I2 equals 2I3. So now you have a relationship between I2 and I3. You can substitute that in there, and that will give you 10 minus 2I3, which is that, minus I3 equals 0. So you've got 3I3 equals 10, and I3 equals 3.3 amps. So that's how you would answer a question like that. So it's Kirchhoff's current law twice, and then we use the fact that the potential difference across these two resistances is the same because they're in parallel.